In this chapter, we'll be talking about a two-dimensional discrete variable, specifically the correlation between variables. Now, we want to examine the degree of linear correlation between two variables using the linear correlation coefficient, and we denote that as the Greek letter rho, or sometimes you'll be seeing that as the letter r. Now, the correlation coefficient has values between -1 and 1, and here we can see examples, right, of connections between two variables, x and y. Okay, this axis is x, this axis is y, for different values of rho. Here, rho equals -1, right, and we have here a perfect negative correlation. Here, rho equals 0, and there's no correlation between x and y. And here, rho equals to 1, and we have a perfect positive correlation between x and y. Now, what does this mean? Well, a correlation coefficient equaling -1 or 1, so we're talking about the edges here. We're talking about rho here equaling -1, or here, rho equaling 1. Well, that means that there's a complete and absolute linear dependency between the variables x and y that can be expressed through the formula y equals ax plus b. So here we have y equaling ax plus b, and again here also we have y equaling ax plus b. Now, a complete positive correlation, that means we're here, right? That's rho equaling 1, means that there's a complete linear dependency where the slope a, right, here the value a is positive. So a here has to be positive. While a complete negative correlation means that there's a complete linear dependency where the slope a here now is negative. Okay, so that means that a is less than 0. Okay, so let's move on now. A partial positive correlation means that as one variable increases, the other has a tendency to increase in value, but there's no linear formula absolutely connecting x and y. Similarly, a partial negative correlation means that as one variable increases, the other has a tendency to decrease in value, but there's no linear formula absolutely connecting x and y. Now, let's take a look at an example here. Here we see examples of partial correlations, okay? Right? Partial positive correlations and partial negative correlations. So let's take a look at this, where rho, right, equals to 0.3 or 0.8. Well, here we have a low positive correlation between x and y, and here we have a high positive correlation between x and y, but we still can't describe the connection between x and y as a mathematical formula. Okay. Similarly, here, that's the mirror image here between x and y, okay, where rho equals -0.3 and rho equals -0.8, where x and y. Okay, we can see that there's a connection, a negative connection between x and y, right? As x increases, y decreases, okay, but we still can't describe the connection, right, between x and y as a mathematical formula. Okay, now what else? Well, we can see then that as we move away from 0, right, and come closer to the edges, right, and it doesn't matter whether we come closer to -1 or 1, then the connection between x and y becomes stronger. Okay, from 0, that's no correlation, to a perfect correlation. Here, perfect negative correlation. Here, perfect positive correlation. And similarly, as you move away from the edges and come closer to the middle, to the value of rho equaling 0, then the connection between x and y become weaker.